Uh, Today we're talking about achieving a No.4 finish. So I think it's best that we actually set the scene for what we're going to do today and have a look what actually we mean by a No.4 finish. So as it says on the slide here, don't worry, there's not too many slides, only a few to go through. No.4 finish is actually an industry standard. It is, as we say, the most common finish, and it really is generally suited to the stainless steel industry, because remember, carbon steel always has to be painted or covered with some kind of layer, so the finish is not so important. But on stainless steel, it's generally left naked, if you like. So no finishing, no paint, no galv, nothing. It's not required because it doesn't corrode quite as easily as carbon steel. So what we need to do with stainless steel is make it look nice. And one of the ways to do that is by applying a No.4 finish. It gives really low gloss compared to a lot of other finishes that we see out there market, like a 2B, for example. The reason for that, why that's good, is because when the actual stainless steel item is in service in your high street or shopping centres, whatever, like balustrades, railings, in the lift, on the escalators, this low gloss brushed finish actually gives long service life without actually requiring to be cleaned. So it doesn't show up dirt and grime, etc., that is applied by high traffic areas. So it's a really nice cosmetic linear scratch finish that is relatively easy to achieve. Next, so how is it done exactly? So it is produced by sanding, what we're going to show you today, and generally with belt sanding. Even in the factories where they actually produce the stainless steel, they send it out with typically around about a No.4 finish, which is about a 0.5, 0.4 RA. It depends what kind of industry, whatever the component is going into, whether it be a dairy or a medical industry, and that finish level measured in RA, which is roughness average, is extremely important, in the food industry and the medical industry, to stop bacteria or contamination forming on the products itself. So it's not just a cosmetic finish here, it's actually a technical finish that can be required by end users for applications. Robin, if you'd like to take us through the Rapid Prep family, because this is your baby, yeah?
Yeah, thank you, Paul. So we have three different types of material. Basically, the difference is on the degree of stiffness of the material. The more stiff the product is on the right-hand side, the LF, which is mainly used for disc applications, perhaps on a right angle grinder. But the two products on the left you can see are the RF and the XF. The XF being the most flexible, extra flex, where that's mainly used for small file belt applications. But the product that we're going to be focusing on today and taking a look at to generate the finish that Paul just described is the RF material, which is a regular flex and is mostly used for what we would regard as narrow belt applications, similar to the type in the machine that was behind Paul when we first had the introduction. There are two types of grains available in the material, our basic aluminium oxide, but we also have the vortex grain in there too. But yeah, carry on, Martin, with the slide. Yeah, so like I said, three levels of flexibility, and we have a wide variety of uses and applications spanning those three types of material on our surface conditioning material rapid prep belts.
And it's fair to say, Robin, as well, with when you were using non-woven surface conditioning belts, we have to change the speed of the machine, really. So it's normally when you're using a coated abrasive belt, that's 30 meters per second, 35 meters per second is a very common belt speed. But when we start to use a non-woven belt, so especially the rapid prep belts, we need to reduce this down. So a speed of anywhere between 15 to 20 meters per second is better, due to the fact we don't want to create heat in the application or potentially smearing the belt. Okay, so a little bit about applications here. So with Rapid Prep, we can remove all sorts of surface defects and give a really nice finish. It's very easy to use. It's very gentle to use. It's very good for deburring products, and there's no chance of creating damage in the material when you're using these kind of belts. So The consistency of the belt is also absolutely key. With a coated abrasive belt, the finish from a coated abrasive actually changes throughout the life of the belt as the grain fractures and gets duller. So it will be say for example, a 60 grit belt will finish finer as it gets older. With non-woven rapid prep, that finish is consistent throughout the life of the belt because of the 3D nature of the product. We can also reduce steps from the application. So conventional coated, you normally jump grits of maybe 40 grit times. You'd start with 60, then a 80, maybe a 120, a 150, a 180. But with employing the rapid prep surface conditioner belts, you can jump these steps. And again, we will show you that and why that's possible today. One of the key points that we have, one of the real additional benefits we have in our rapid prep material is our clean bond resin technology. One of the difficulties with any non-woven product is what I was referring to earlier, is heat and smearing and the product actually melting, which obviously if you melt the product onto the material you're grinding, you need to then remove that. With our clean bond resin technology, this actually resists the phenomena of loading onto the material a lot more than any of our competitors. So it's a real big advantage to have this clean bond technology inside our rapid prep material. Okay, so here we are again, back with me. So I'm going to show you a little bit about this machine before we start. This is a Metabo backstand grinder, twin head, as you can see. We're going to use this wheel today because it's closest to the camera. It's pretty simple as that. I think it's an 8 kilowatt machine, so it's a pretty powerful beast. We have a large contact wheel here, and we will be going through belt changes on this machine because we're going to use 4 different types of belt on here today. And yes, we have to be very aware of what we're doing on this machine as well, because it is a bit of a beast. So we have to make sure we've got all our emergency stops, the one on the floor here, one on here, and one on the actual guard itself. So if anything goes wrong, we can switch the machine off very quickly. I also need to pay real attention to the PPE, the personal protective equipment that I'm wearing today, because it's a belt. You know, you may think a coated abrasive belt is not so aggressive, but these machines are designed to remove metal in huge pieces of metal very, very quickly, as well as finishing what we're going to do today. So I'm going to be wearing some leather gauntlets today rather than the normal gloves I would wear when I'm using a portable tool like an angle grinder, just to make sure if any of my parts of my hands come into contact with this wheel, I'm not going to get any issues with abrading my skin away. Also, I'm going to be wearing obviously flame-proof overalls, my safety boots, ear defenders, and a face mask as well to avoid any sparks going anywhere and causing any damage today. So yeah, it's a beast of a machine. What we're going to be doing is we're going to be achieving a number 4 finish on this box section steel we have here. This is how it would look in any customer when they have the steel on in their stores, straight from the factory. It has a finish applied to it already, and then it's formed into this box section. It's welded. I think you see the weld is down this side, and then they give it another little finish again, to be honest with you, just to brighten it up a little bit. But the problem is, when it arrives to the customer, it's covered in damage, scratches, scrapes, and marks all over it. So if we're trying to achieve a decent finish on that, or a dairy or a medical finish on this item, it's really not looking so good at the moment. Cosmetically, it needs to be improved. So we need to take out all of the scratches and then reapply that finish down to the 0.4 RA, or the number 4 finish that we're going to achieve. And the way we do that is with belts. Okay, so a combination of belts we've got here in non-wovens, but first of all, we need to use a coated abrasive belt to actually remove the deeper scratches and the damage on the surfaces. So what I'm going to use today is a belt. It's our 946 belt. So it's a cloth back belt, ceramic abrasive on here, and I think you can see that in the camera there. So our 946, it's a ceramic abrasive on here, and also the backing. It's a very flexible backing on here. So we've got a J-weight cloth backing. Again, the reason I'm using a J-weight flexible backing is because I don't want to force the abrasive into the material. I want to be as kind as I possibly can to the material. So I'm not going to use a heavy cotton, X-weight cotton or Y-weight polyester belt, because we will put the scratch too deep in the material, and then we'll be struggling to remove that later on. It will take longer to remove that later on with the Rapid Prep belt. So it's a ceramic abrasive. Yes, it's aggressive, but 80 grit. Again, I don't want to use a coarse grade because I'm trying to achieve a really nice finish for this. So I want 80 grit or 120 grit is pretty much ideal for me. Again, not big particle size, but we do need to do a little bit of work. So it's a happy medium at 80 grit. I've already installed a belt on this head because it is a little time consuming to change these belts over. So we will get ahead by having this belt ready to go. One thing as well, actually, this material, you can see by the nature of it, it's quite a matte finish on there. This means it has our what we call a supersize layer on here. Okay, what we mean by supersize, it's a layer of additive that we put on top of the abrasive to actually cool down the grind when we're grinding stainless steel. If you tried to grind stainless steel with a non-supersized product, you would actually create burn. All right, with this supersized layer we put on top, it dissipates the heat, takes the heat out of the application, so we avoid any possibility of burning the stainless steel surface. Right, so we might as well get on. We've got quite a bit of grinding to do. I'm just going to get rid of that belt down there for now because we already have it on the machine. I'm going to get my PPE on and we'll finish the component. I'm going to take this component here. I'm going to do all 4 sides with the grit 80. Then I'm going to move on to the coarse grade Rapid Prep, and I'm going to leave one side with P80 and finish the other 3 with the coarse grade product. And then I'm going to pick a medium product from the Rapid Prep family, and I'm going to just do 2 sides. And then finally, we're going to finish on one side with very fine only, and that's where we will have our number 4 finish. And then we can compare what the finish looks like from a P80 finish to a very fine finish. Okay, great. Right, let me get my PPE on. Anything to add, Robin?
No, you've covered quite a lot already there, Paul, with the explanations on that. So just to emphasize again about the super size on the belt that you're just about to use.
Yeah.
Very important point to highlight again, that the fact that you want to keep the metal cool.
Yeah.
And that super size coating on the belt does exactly that.
Yeah, it does indeed. Yeah, heat is our enemy with stainless steel. It really does react badly, and it can go blue or brown in color if we put too much heat in it. So we want to be quick and light, and not to damage any of this surface. A little word about this machine. It does take a little while to slow down. So while we're doing that, we'll turn my microphone down because it's a pretty loud machine. So I will wait till the machine stops before I talk and we have a look at the surface finish. But Robin will keep you entertained, I'm sure. Okay.
Paul, just before you start again, it's worthwhile just one more time, just to show the condition of the metal that you're just about to put the first belt stage on, just so that we can see it holding it different.
Yeah, it's a good point, but I've got another one here, Robin. So when we finish, I will show the condition of this unfinished piece versus each step as we go through the belt stage. So yeah, we will have a look and compare and contrast what that finish looks like compared to how the steel arrives at the factory. Right then, so I've got all my PPE on and be ready to go. I'm just finding out how difficult it is to write on something with these gloves on. It's impossible. My handwriting's not the best anyway, to be honest with you, but actually it's probably better with these gloves on. So we've achieved a grit 80 finish on this on the material now, so I can quickly show you how that looks on camera. I think we can pick that up. So this is the on this side, this is the grit 80, and here is the unfinished product. As you can see, damage on here, where, as I said, storage damage, moving damage, whatever. It's a pretty dull finish on this as well. But where we've finished with the belt, you can see it's extremely bright now, okay, because the abrasive grains have cut into the surface and made that, you can almost see the scratches of the grains as they've gone past that surface of that steel. But that's too bright for us. The finish is too coarse. Probably be about 1.5, 1.4 RA, around about that kind of finish, and nowhere near the 0.5, 0.4 we want to get to for the number 4 finish. And now we have to refine that finish a little bit more. And this is where our Rapid Prep belts come into their own. So 3 different belts I'm going to use today, but I'll show you all 4 that I have here on the tool. First, we have a coarse grade, as I said before. You can always denote which is a coarse grade non-woven belt, pretty much due to the color. We don't print the grit size on the back like we do on a conventional coated, because it's very difficult to print a grit size on this on the back of this material. So instead we color it to note the grade. And that's an important phrase to use for non-wovens Rapid Prep products, is we don't use a grit size, we use a grade. So you might say, well, coarse. Well, what is coarse? It actually contains about P80, P120. So very similar to this coated abrasive belt grit size, but due to the 3D nature of this this product, because it's softer, it doesn't act like a grit 80. It acts a lot finer than that, because it's basically like your car suspension. It compresses when you push onto it. It doesn't push the grain into the material. So even though it's a very equivalent grade to the P80 coated, we get a completely different finish from that product. And that goes through all of the belts. So we have a medium belt here, which we'll talk about a little bit about later. We have a fine and a very fine, all with their individual colors. But first of all, let's get this coarse belt onto the machine. I'll put this one out of the way. We'll open it up. A little bit time consuming to change over on these machines. Obviously, if you see me doing this, it's one of the most time consuming parts of doing any finishing job with a backstand machine. So the longer service life you can get from your belts really does give you an advantage here, because this is downtime. This is non-value added time while I'm doing this. So the longer the belt lasts, the better. And I think we can safely say our Rapid Prep belts have a really good lifetime when compared to conventional coated and other competitive products out there in the market. So we slide this on. You have to be tall for this. Luckily, I've got my high heels on, so I'm okay today. No, safety high heels.
Well, we were able to see the flexibility of that product that you mentioned earlier on there. You could really see the belt flexing.
Yeah, you can. So I'm just tensioning the belt now, and I'm clamping it off. And little tip, when you're tensioning the belt, you say, well, how tight do you need to get the belt? Well, it's almost like when you're doing the fan belt on your car. I don't know if anybody of you ever worked on your car before, but if you can twist the belt about halfway and it starts to resist that twist, that means you've got it pretty much tight enough. It's really a gauge like that to check your tension. So let's move it over on the wheel a bit. So again, we're going to do the same step, but on 3 sides of the metal, leaving the P80 finish, so we can compare and contrast what that finish looks like. When I first start the belt up, I'm just going to have to make sure it tracks right, because it's a different shape belt. It's a bit heavier than the coated belt, so it just may move a little bit on the contact wheel. So I'm going to adjust with a little adjustment bar I've got here to track the belt going in the right direction. Okay, so let's start. Okay, sorry, I'll take my mask. So now we have our coarse finish. Remember me saying that the grades and grits inside these products are pretty similar. But I think now if we can show, I'll turn it the right way around, if we can show a P80 finish I achieved earlier versus the coarse grade of the non-woven, you can see, so we have the non-woven finish here and the P80 here. You can see those bright sparky lines that you have on the P80 finish are starting to be blended away. All right, so we're getting a much more homogeneous kind of finish on there, and you can easily see that. You've even taken out some of the dents and marks on the surface structure. You see it's a lot smoother now, having used the non-woven belt, again because of the softness of the product, the conformability of the product, and just the nature of a rapid prep belt works on your component. So yeah, it's already starting to get nice. We'll be about, I think, about 0.8, 0.9 RA at this stage, around about that kind of finish. I'll just juggle these about. I'll leave my finished component here. I need to write on here as well, coarse grade, with my gloves.
So we're seeing those finish differences pretty well, Paul, on the it's coming up pretty good. Excellent.
It's impossible to write with these things, right? Okay, so let's change the belt over now. So again, you may wonder, I'm not switching off the machine when I'm changing the belt. The reason I don't need to do that on that machine is because we have an isolator switch. So as soon as I take open this guard on the side of the machine, there's no chance the machine is now cut off. So there's no chance it will start while I've got my hands inside here. So safety first. So slacken off the belt. And we can take that off there. Okay, so now we move on to the medium grade belt. So what I'm doing now is I'm now blending, again, the scratches that are left, or the finish that's left from the coarse grade belt. So I'm going to use the Rapid Prep medium. Always maroon in color, I think is the best way to describe this color. This has about a grade 150, 180 in this product, around about that kind of grit. But again, it achieves a much finer finish than the conventional coated product with that equivalent grade on there. So let's get it in the machine and get that piece of bar finished. Easier said than done. Hold on.
So these products come in 4 different grades. So from coarse, as Paul has just demonstrated, to the medium, which is the more maroon color, the green, fine, and then at the end, the very fine, which is a blue color.
Yeah, we have all of those here as well, as you say, Robin. So as Robin says, we have the green here, which is our fine grade product, and not everybody has this in their offering. This, so about P220 in this product, and then our very fine product, which is always blue, P220, P280, P320, around about this kind of grade size, all made with the same backing, all the same material, just a different type of abrasive, different size abrasive grain inside. Right, so we're tensioned, and I think we're almost tracked. So I'll finish now, not the P80, not the coarse. I'm going to do these other 2 sides where we have the coarse grade, and then I'll finish finally with the very fine on the last side. Just a little word about the contact wheel here. So this is what we call a contact wheel on a machine. It's very important, the grade and type of contact wheel that you use for this finishing step. So ideally, it needs to be anywhere between 40 and 60 Shore hardness, that's Shore A, to ensure, again, that you're not pushing the abrasive into the product. It's soft, it's smooth, it's conformable, it bends a little bit when you when you're putting pressure on there, or putting your component in there. You don't get chatter marks on there from a ridge wheel. This wheel's a little bit hard today. It's about a 60-70 Shore wheel, and it is serrated, so it does have serrations in there. Normally that helps with aggression in that application. So if you're using a 36-40 grit belt, it helps the belt bite into the material that little bit more. But it's only, I think, 3-to-1 land to groove ratio. So for today, it's okay. I would prefer a little bit softer and maybe a plain wheel to get the perfect finish. But most customers are not changing their contact wheels. So these products have to be able to withstand and produce the right finish, even with the wheel that's not exactly ideal. Right, let's start up the machine again, and I'll track the belt, and then we can start to get our medium grade finish.
You see that the end result are different again from the original E80 ceramic grade build. Kind of finish that leaves here.
Right, just mark on here medium on that one side, and then I'll show you again the finish we have compared to the P80 after our first grind, because I think that's the most visual difference. We can take that to the camera again, a close up on Martin.
You can keep tilting, Paul, that'll be helpful.
Yeah, difficult to focus on this. So yeah, there we go. You can see again, we're getting really fine finish on there. Again, a lot of the damage taken out from the rolling process, and the scratches looking very uniform. This finish could be good enough for some people, for some customers. That may just be cosmetically good enough for the application. And I think if you're trying to think where you would see this finish would be probably in your own home, to be honest with you. I mean, when you look at things like the handles for your cooker, your refrigerator, what we call white goods, often this is the finish that is good enough for them, because they are high use items. We're grabbing that, pulling it open, they get knocked, they get scraped. If it's too fine a finish, then that damage that's done over the time can look quite poor. So this kind of finish is pretty good for these really high traffic areas such as handles and doors, etc. Even the front of your fridge at home. I certainly have a stainless steel one in my kitchen, and it is this exact brushed finish on there, not too bright. But we're going to go a step further and use our very fine belt, which is the blue belt here. You may wonder why I'm not using our green belt, the fine grade belt, and why I'm not using that as a stage. I mean, you can if you want a really flawless finish, but to be honest, we can miss a step here. We can go straight to the very fine because we already have a good finish from the medium. It will probably be a little bit better with the green belt, but you can miss a stage here and jump straight to the very fine. And again, we were discussing on the PowerPoint how this product can help you to reduce grinding steps if you're using conventional coated. We can get to a No.4 finish in 4 steps alone. So it's really handy. It's a very time consuming operation. Okay, let's get this belt off. Untension. Put him down there in my perfect storeroom on the floor. Let's get him on.
When would you say we are now in terms of RA after that last step?
Sorry, Robin, what was that?
I was just asking Paul an open question. Where would you say we are in terms of RA level after that last step?
After the medium grade, I'd say we're around about 0.6 to 0.7, I would say.
Okay. So you can see how we're getting to in the progress that we're getting from what Paul showed in the slides earlier on in terms of some of the finish levels that are required in industry. Yeah,
and we talk about, like we say, medical finishes, Robin, and And probably one of the, besides the medical, one of the more important is the dairy finish. So we mean food standards, so food hygiene. So all your milk tilers and tanks and pipe work that you're having in factories, etc., even down to the stainless steel kitchen surfaces. That's where we're looking at with these kind of products. That's why it's important that we achieve that finish, and it's completely again, we use the word homogeneous all the time, so it's a consistent finish across the whole width. Right, last stage now. The belt's on. Let's get the machine started. I'll track the belt again, and then I'll do the final finish on one side of this, one remaining side of this piece of material, which is this one, and make sure I get that right. Okay, off we go.
Yeah, as you can see, another evidence there of how quick and efficiently these belts will deliver that finish level.
Brilliant. Okay, as you can see, that was really quick to do, to be honest with you. It takes very little pressure, very little time. And also, you probably noticed when the camera was at this angle, when you're getting ever finer on these products, there's barely any sparks. And the reason is because we're really removing hardly anything from the surface of the material. If you weighed this before and after, there wouldn't be hardly any difference in the weight of the component. All we're doing is we're taking off the peaks off the valleys and troughs that we've got. Sorry, the valleys and the peaks on the surface. So we're just taking that top layer off and bringing that down, which gives us a lower roughness average, so a lower RA, as we say. So that's the finish now. We've got the very fine. So let me first of all show you that versus the Grit 80 product, and then I'll show you where we started as well. So if we get the camera back on the close-up and I work out which is left and which is right, there you can see how the light is reflecting off that. It's much flatter. As we said, it's kind of a nice, it's not a hugely bright finish like the P80, again, because it looks more smooth. Yeah, and again, I'm sure you've seen this finish everywhere you go, as it is the most common. Let's have a look how it looks versus where we started, the factory finish, where the product how the product arrives. And if you have a look here, you can see the difference. So here we have the factory finish. You can see lots of rough parts, scratches, dents and scrapes on the product. On the finished product, it's perfectly flat and uniform, which is exactly what we are looking for. Another benefit you have with this kind of finish is the fact, and the reason for the finish, we said the longer service life without needing to be cleaned, is now when we put our finger and we touch it, you can't see where I've done that, or it does limit the dirt that remains from that kind of thing. And so high traffic areas again are going to really benefit from this this number 4 finish. Okay, so that's it for the number 4 finish. You saw how quick we were able to do it and how easy it is to do. Even I can do it, so it must be really easy. Robin, anything to add?
No, I was just on the last one there, Paul. I'm just highlighting again you get these belts to the desired surface level as quickly and efficiently as possible. It's really, I think the last belt really highlighted it, how quickly you were able to achieve that level.
That's the whole idea of it, isn't it, Robin? Is to do exactly that. Yeah, it really is. And that consistency the product gives you. So even if you've got an automated process with multiple heads and the sheets of material going through your machine, the belts will give you a continually the same finish from the start of the life till the end of the life of the product, and that does help you a lot. One other way that we see customers use these non-woven type products to get an even better finish than we have now is by using some kind of coolant or oil-based lubricant. So if we had an oil-based lubricant in there, it would actually give us an even better finish with that. So I've seen customers use pure oil as a coolant or a lubricant in their process, which gives a really, really special finish to this product. But obviously on this machine, it's not possible because it would be everywhere. So not a good idea for that. But they do withstand coolants, emulsions, and neat oil, whatever you do. They're completely inert to any kind of fluids that you get on there. So yeah, easy to achieve the ultimate finish with a combination of our coated products and our Rapid Prep non-woven surface conditioning belts. Very nice. Okay, so I think that's it for today. Have you got anything to add to that, Robin?
No, it's excellent, well demonstrated, Paul, and we were able to see the difference in the finishes from the camera work from Martin there. So
yes. Yeah, thanks to you for joining and giving some great commentary over the time I'm working on this machine. And again, thanks to Martin for the camera work, as always. Good job, my friend. And thanks to you guys for attending our live streams.